What impact does urbanization have on groundwater recharge? Imagine a city growing rapidly, with new roads, buildings, and parking lots popping up everywhere. This change doesn't just affect how the city looks, it also impacts how water moves through the environment. When land is developed, it often replaces natural surfaces with materials that water can't pass through easily. These are called impervious surfaces, like concrete and asphalt. They stop rainwater from soaking into the ground, which is a key part of replenishing underground water supplies. In natural settings, soil, plants, and the terrain help water seep down into underground layers called aquifers. These aquifers store groundwater, which many cities relying on for drinking water, farming, and industry. But when urban areas expand, this natural process gets disrupted. Instead of soaking into the soil, rainwater quickly runs off the surface into storm drains, rivers, or lakes. This process is called surface runoff, and it means less water reaches the underground reservoirs. Research shows that urbanization can cut down groundwater recharge by 30 to 50% or even more, depending on how much land has been developed. When soil is covered with pavement or buildings, it becomes less permeable, meaning water can't pass through easily. Construction activities also compact soil, making it even harder for water to infiltrate. This results in less natural replenishment of groundwater over time. Cities often modify drainage systems to handle excess water, which can lead to more flooding and less water seeping into the ground. Sometimes, wastewater is discharged into the ground, which can cause some localized deep infiltration. But overall, the amount of water that naturally recharges aquifers drops significantly. This reduction can cause water tables to fall, making it harder to access groundwater and increasing the risk of saltwater intrusion in coastal cities. Urbanization also affects water quality. Less recharge means fewer natural filters, so pollutants from streets and factories can more easily reach groundwater. Increased surface runoff can carry oils, chemicals, and other pollutants into underground water sources, leading to contamination. To counteract these effects, cities are adopting green infrastructure like permeable pavements, green roofs, and rain gardens. These features help water soak into the ground instead of running off. Stormwater management systems like detention basins and retention ponds also slow down runoff and allow water to infiltrate gradually. Protecting natural areas such as wetlands and forests is another way to help maintain groundwater recharge. In the end, urbanization tends to lower the amount of water that naturally filters into underground reservoirs. This change challenges the sustainability of groundwater supplies and calls for smarter planning and infrastructure to keep water flowing where it's needed most.